Hello everyone, here's Mustafa. This is Unit 7 Equilibrium. Our first lesson will be about reversible versus irreversible reactions. Let's get started. Before we start speaking about equilibrium reactions, we have to differentiate between irreversible and reversible reactions. First of all, what is meant by irreversible reaction? Simply, irreversible reaction that the reaction that goes into completion, which means that we have reactants that will react to form products. By the end of this reaction, we might have no reactants. So in the beginning, we have reactants, then after a while, we start making products. Then after a while, we will have only products without any reactants. This is a reaction that's called irreversible reaction, which is start from reactants. All the reactants could end up by forming the products. Sometimes you could have some reactants which are excess, of course, but if we have the exact amount of reactants, we could end up by having all the reactants converted into products. You can see here is the reactants. Of course, the rate of reaction is very fast at the beginning because we have high concentration here. We have no products in the beginning. After a while, we have, as you can see, as you can differentiate between the first stage and the second stage. In the second stage, we have lower concentration because some of the reactants have already reacted to form products. By the end of the reaction, we have no more reactants, but all the reactants have been converted into products. We can see here from this graph that all the products, can you see, the products start from zero. This graph, which is representing the concentration against time, all the products have been formed, fixed products, fixed amount of products, started from zero. Reactants started from a high value, ended by zero. So we have used all the reactants to form the products. This is irreversible reaction. I will give you an example about the irreversible reactions, like the combustion reaction. Combustion reaction for anything like the combustion reaction of methane, it will form carbon dioxide, water, and of course heat will be produced. This is an example for the irreversible reaction. What about the reversible reaction? The reversible reaction the reaction that can go both ways. So we start by having reactants. After a while, the reactants will react to form products, and this is the case. Reactants can react to form products, and the products as well can decompose or maybe react to form reactants again. Here's an illustration for the reversible reaction. We can see here we have already started with this amount of reactants. They reacted to form products. Then we reach it to a state where we have reactants and products. The reaction can go both ways. The reaction can go both ways. It's different than the irreversible reaction. It is clear from the arrow. This arrow is going both ways, but for the irreversible reaction, it's going just one way to the completion. We can see a graph for this reaction. Here is it. The products, okay, and the reactants are available, okay. Why? Because the reactants could react to form products, and the products could react or decompose to form reactants. So we have both reactants and the products available in the system. This is simply the difference between irreversible and reversible reaction. We don't have to forget to to show the arrow which represents the type of the reaction. If it is irreversible, it's one-way reaction, goes to completion. By the end, all the reactants or maybe some of the reactants will vanish or consumed, and we will have all the products or the maximum amount of products that could be produced. But for the reversible reaction, we have reactants and the products at the same time in the system.